So hey guys, welcome. Thank you for coming and stopping by. I'm Edgar. I'm the Vice President of Technical Operations over at Lumina Networks. And I wanted to share a little bit about some of the things we have going on, specifically SD Core, and give you a little demonstration about our products, the Lumina Networks SDN controller and the Lumina Networks Flow Manager. Right? With those two products, I'd like to demonstrate some basic SD Core service management or control, right? Well, I'm going to be showing an E-line, which is essentially a layer 2 service based on Ethernet to really connect a point-to-point two Ethernet ports at different ends of the network and let our customers exchange data, right? The purpose of my demonstration, again, introduction to SD Core, introduction to our two products here, the SDN controller and the Flow Manager, and ultimately demonstration of how those tools work. A little bit about our products. The Lumina SDN controller is an ODL commercial distribution. It kind of keeps state of the network. It's the place where the applications that are going to control the network find information about what the network is doing, what the network condition is, and also install information about what they want the network to accomplish. Right? And that controller then translates that into whatever is necessary from the network, whether that's open flow rules, whether that's a netconf instructions, whether it's BGP. It's kind of a universal translator in that sense, from what the applications need from the network to what the network needs to accomplish the goals, right? We have our Lumina Flow Manager, and that's an application that sits on top of the controller. It makes the controller, gives additional capabilities to the controller in such a way that applications and developers of those applications can quickly develop solutions to what their business needs are, right? So it provides some key capabilities, keeps track of paths of the network, lets you define those paths, tell you the status of those paths. It tells you about the visualization. It understands different aspects of the network that it's controlling and takes that information and draws a picture for us. That's a pretty useful thing, right? It lets us lets us define how we want packets to use the paths that we're defining, right? In this demonstration, we're going to be using an MPLS data plane, which is pretty typical. I think it's the most standard way in which service providers define services today. So it's important, if we want to help that transition from a standard or a contemporary IP MPLS network into what we want to build in the future, we're going to want to integrate at that MPLS layer. That's not the only way it can work, but that's just the way this demonstration is built for today. At the end of the day, the Flow Manager kind of abstracts, the nitty-gritty of OpenFlow, of netconf, of just managing networks from the person or the people or the team developing applications that will ultimately use the network. Again, Lumina SDN controller, or we like to call it LSC, or Lumina Flow Manager, LFM. So the basic idea, again, we have a software-defined core, right? That's the yellow box. It's a collection of switches, right? And we have two CPE devices at either end of the network. And what we want to accomplish is just basically tie those two guys together. Layer 2, simple E-line, the most basic service you can define. So how are we going to do this in the demonstration? This is our architecture here. This is us, right? Here at the keyboard, we're the user. We have two ways to interact with the system. We have a web UI, and we have a northbound application. In this case, Postman is standing in for that. It's just an API test tool. And we're going to be interacting with Flow Manager, and we're going to be interacting with the Lumina SDN controller. That controller will speak to NoviFlow switches. These are physical switches, and also a mini-net topology, right? A software simulation of a network, right? And across that network, we will build the E-line service, and we'll get our two CPE devices to communicate with each other. So this is some basic details there. Our first step is going to be basically just let Lumina Flow Manager build the path the way it wants to do that, right? It's basically going to use the shortest path first algorithm. It'll build that and make sure we can evaluate that. Then we'll go ahead and tell it to do something a little bit more special. We'll give it some constraints about where we want the data to flow in the network, and then we'll build that path as well. At this point, I'd like to introduce to you the user interface of Lumina Flow Manager. This is essentially what we have here at our base. It's our network topology. This is all discovered. These are all OpenFlow switches. This was all discovered by by the controller and structured as a graph there. You'll see it update every now and then and rebuild the graph for us, right? So the most basic function, just to demonstrate, is adding a path to the network. We can use the web UI, we can use the REST API. In this case, using the web UI is pretty simple. We just tell it, hey, we want a path from this point to that point, right? We can go ahead and name that path. Right. And we can save it. Okay, so it tells us the path has been added, right? The next thing you want to do is, well, what happened with that path? We'll head over to our view path, and it'll give us a little drop down here and say, hey, let's take a look at where that path is. Pretty simple. Obviously, those two switches are connected together, so it shows the shortest path between them, right? We can look at our contents of our paths. We can see our paths, where they start, where they end, what the status of that path is, what type of path it is. It's an MPLS path. We can look at the details of this path, right? No waypoints, MPLS, et cetera. Very rudimentary interface, but useful for evaluating the product, useful for running scenarios quickly and easily. You don't need to build an application or know a lot of programming. It just kind of helps you get to where you're going quickly, right? Again, most of our users will use the REST API, so let's go take a look at what that looks like. Right, so this is our Postman standard tool, and what we're doing is running REST calls with a URL. We have a body. Oh, this one doesn't have a body, but for instance, we can collect data about what paths are defined in our network. Right, so here we made a request. We got back information. This is the API or the northbound application interrogating the controller, getting details about the path that we created. Right? In this case, now let's use the API to build a path. The path, here we go, standard REST API call, and our a body of our message. We'll go ahead and send that across. We can go back and check to see what the status of that path is. And there we go, we have that guy. Right, this is the path we just created, point-to-point MPLS. Let's create a second path here. This time we want to do something a little bit different. Like I mentioned, we want to have waypoints or constraints to our path, right? So we tell it, hey, we have some constraints. We want some waypoints. We have some specific switches we want the path to traverse. We'll go ahead and send that as well, and we can always check our paths again. We had one. Now we have two paths. So let's take a look what this looks like in the GUI. We have a couple of paths here. We have our first path. Right, whoops, this one shows us, again, just a basic shortest path. Let's take a look at our second one with the constraints, and this tells us, hey, this guy goes around the long way. Right, so it's the most basic demonstration of what's going on here, right? Now, the final piece to building a service is you have to build those service classifiers. We've built the path, now we have to tell it, hey, what's going on in that path? What packets do we want to put on that path? And that's also done through the REST API. Here we'll define our path. Here it is. All right. With the body, we'll tell our system specific ports on specific switches, and they're tied to a specific path. Right? In this case, the MPLS path. And we have a status 202. It's good, and we can check the status of our services. They've been defined. They're in the database. Their state has been defined. Right? So, going back to our presentation here, we built a simple path. We built a constraint path, going a long way. We defined our what data enters those paths. So we have everything we need to build a service and service our customers, giving them whatever type of network connectivity they want from a layer 2 Ethernet service. Right? This is important. This ability is the fundamental, the idea that we can pool data from the network, instruct the network to create, to make changes. All of this from a standard application interface, right? We're interacting with standard network technologies, the MPLS transport layer, and we understand the relationship between the services that those MPLS applications use. This is fundamental and important to the transition that we're going through, the transition between traditional IP MPLS networks and SDN networks of the future. This ability to translate those services from the legacy networks to the new network, span across them, is fundamental and important for our path forward. So thank you very much for your time today. That was my demonstration. Happy to answer any questions. Thank you very much.